In 2022, the James Webb Space Telescope looked back to the very edge of time, to a universe less than 700 million years old. And it found something that should not exist. A black hole, already fully grown, already billions of times the mass of our sun. Scientists ran the numbers, then ran them again. Something was wrong. Not with the telescope, not with the data, with everything we thought we knew.
To understand why this black hole is so impossible, we first need to understand how black holes are supposed to form. Stars are born from clouds of gas and dust, hydrogen pulled together by gravity over millions of years. They burn, they explode, they collapse. When a star massive enough dies, it leaves behind a black hole, a point of infinite density, wrapped in a boundary that not even light can escape. Simple enough, that's the playbook. But here's where it gets complicated. For a black hole to grow supermassive, to reach billions of solar masses, it needs time. Billions of years of feeding, consuming gas, stars, merging with other black holes. Our own galaxy's black hole, Sagittarius A star, took nearly 13 billion years to reach its current size. So when astronomers pointed the James Webb Space Telescope at the early universe and found a fully formed supermassive black hole already sitting there, fat and heavy, in a universe that was barely 700 million years old, the silence in the room was deafening.
This object, cataloged as UHZ-1, should not exist under any model of physics we currently have. And it is not alone. The James Webb Space Telescope launched in December 2021. Its mission was simple: look further back in time than any telescope before it. Because looking far away in space means looking far back in time. Light from a galaxy a billion light years away left that galaxy a billion years ago. Webb could see light from the very dawn of the universe. What it found stunned the scientific community. Not one impossible black hole, not two, dozens. In galaxy after galaxy, in the universe's earliest eras, Webb found supermassive black holes that were simply too big, too early. Dr. Priyam Vadanatarajan, a theoretical astrophysicist at Yale, described it simply. We may be seeing, for the first time, a completely new pathway for black hole formation. A new pathway. In other words, our textbooks may be wrong. But here's what nobody is talking about. If these black holes formed faster than our models allow, what else formed faster than we think? Three theories have emerged, each one more unsettling than the last. Theory 1. Direct collapse. In the very early universe, conditions were different, denser, hotter. Some scientists believe that massive clouds of primordial gas, instead of fragmenting into individual stars, collapsed directly into a black hole, skipping the star stage entirely. No supernova required, no waiting millions of years, just instant black hole. Theory 2. Dark matter seeds. A more controversial idea suggests that dark matter, the invisible substance making up 85% of all matter in the universe, may have seeded early black holes directly, not through stellar death, through a process we do not yet fully understand. Theory 3. We are wrong about the age. The most radical possibility? The universe is older than we think. That somewhere in our calculations of the Big Bang and cosmic expansion, we made a mistake. Each theory, if confirmed, rewrites a chapter of physics. None of them have been proven. All of them keep scientists awake at night.
If you're finding this as mind-bending as I am, you're in the right place. Cosmos Vox exists for exactly these questions, the ones that don't have clean answers yet. Hit subscribe so you don't miss what comes next, because the universe is far stranger than anyone expected.
When astronomers combined Webb's infrared data with NASA's Chandra X-ray Observatory, they discovered that UHZ-1 was consuming material at a rate far beyond what should be possible. Normal black holes feed steadily. UHZ-1 was gorging, releasing energy equivalent to trillions of suns, all from a region no larger than our solar system. This process, called hyper-Eddington accretion, was theorized but never observed in the early universe before. And it solves part of the mystery. If early black holes could feed this fast, faster than physics said was possible, they could reach supermassive scales in a fraction of the time our models predicted. But it opens a deeper question. Why did the early universe allow this? What made conditions then so different from now? The answer may lie in what the universe looked like in its first few 100 million years. Hot, dense soup of hydrogen and helium, with no metals, no complex chemistry, no interference. A perfect feeding environment. A universe built for black holes.
We look up at the sky and see silence. But scattered across that silence, at distances so vast, light hasn't finished traveling to reach us, are objects that break our rules, that existed before they should have, that grew faster than we believed possible. UHZ-1 is not a glitch. It is a signal. The universe is telling us that our map, however detailed, however precise, is still missing entire continents. And the only way to find them is to keep looking.
That's the story of the black hole that shouldn't exist. If this made you question something you thought you knew, leave it in the comments. I read every one. Next episode, we go even further back to the first second of the universe and what should have destroyed everything before it began. Subscribe, stay curious. The cosmos isn't finished with us yet.